Today we're going to talk about factoring, and it's an actual reversing distribution. So you'll recall from when we had to distribute, we took this x and multiplied on the 4x, and we took the x and multiplied on the 3. So we had 4 times x, which is 4x squared, and x times 3, or 3x. Now these two terms here, after we distributed, these two terms have a common factor of x. We took the x and distributed it so that now each of these two factors have this common factor of x. There's an extra x in here, and there's an x in there. There's two x's. This is 4xx, this is 3x. They both have at least one x. And so the greatest common factor for these two is x. It's the same idea here. We take these three x's and we distribute them to both terms. Then this term is going to have a factor of 3x, and this term is going to have a factor of 3x. So the greatest common factor for these two new terms is 3x. See that? 3 times 2 is 6. This 6x has a factor of 3x in it. 3x times 3x is 9x squared. This 9x squared has a factor of 3x in it. In fact, the greatest common factor in this term and this term is 3x. So when we factor then, we are reversing the distribution. If you look carefully at these two terms, you can see that both of them have a factor of x. So we could just as easily divide out a factor of x from both, divide out a factor of x from this term, and divide out a factor of x in this term, and we would get 7x to the first power minus 9. But since we divided out an x, we can't just throw that x away. The x that we divide out, we multiply back in. So we really haven't changed anything. This is exactly the same expression as this. You can put these two expressions in the calculator and they will graph on top of each other. You should try that. Okay, let's look at these two terms. This has a factor of 2 and an x in it. This has a factor, this has two factors of 2 and an x. The greatest common factors are, well actually there's actually 2, and they are, let's see, a 2 and an x. 2 is a factor of this, and x is a factor of that. 2 is a factor of this, and x is a factor of that. So we could divide those out, and that would leave us with a negative x plus 2. See that? Take out 2x. That's going to leave us a negative x. Divide out a 2x. That's going to leave us a 2. But we can't just throw those 2x's away. And again, if you distribute these, we would be going backwards and get our original term back. Terms, both of them. Watch this. 2x times negative x will give you negative 2x squared, right? And 2x times 2 is 4x. So we're going around in circles. What you need to be able to do is pull out the common factor, the greatest common factor from both terms, write it on the outside, and then the leftovers in the parentheses. So most kids get the idea, okay, so this is distribution done backwards. But then the question is, well, what do I pull out? And it isn't so easy for some people just to look at these two terms and say, oh, well, the greatest common factor is. So what I'm proposing we do is factor each term. like that. 15 is 3 times 5. Those are your prime factors for 15. Make yourself a little tree, that's all you're going to get out of it, 3 and a 5. And the x squared is x times x. Then we're going to subtract, here's our other term, 3 times 3 is 9, and an x. Now when you look at these two terms, all prime factored out, it's easy to see they both have 3. And then it's easy to see they both have an x. So that's what you're going to pull out. You're going to pull out the 3x. So we have y equals 3x times. All right, we got some leftovers here. When we take out 3x from both terms and put it on the outside, undistribute it, take it away, then this term is left with a 5x, and this one's left with a 3. Let's try this one. Now, 10 factors out, prime factors are 2 and 5. 2 times 5 is 10. Those are both prime. Can't break it down anymore. You can make a tree if you want, but it's not going to be a big tree. And 3 g's. Minus 3 and a g. 3's prime. There's nothing you can do with it. Now when you look at those two terms, you see you can pull out nothing in the constants. These two don't match anything over here, but you could pull out 1g from both terms. So you're going to have a g on the outside. Then, on the inside of the parentheses, you're left with 2 times 5 is 10. G is g squared. And then over here you have a negative 3. Let's try this one. Okay, you have a negative 2 times 2. That's 4. XX minus 2 times 3 times x. Looking for common factors, you see they both have a 2. And then look, they both have an x. So you're going to pull out a 2x. Oh look, this one's negative and this one's negative. Why not pull out the negative sign too? We're going to pull out the negative sign too. Negative 2x. So that takes care of the negative and the 2 and the x. And then over here, the negative. Oops, this might get too messy to try to show that. You're going to take out the negative and the 2 and the x. And that leaves here just 2 and a 3. And let's see, there's got to be another x somewhere. Right there. I took one x. I should have another one right there. Well, let's test to make sure we got it all. That got a little confusing. Let's multiply it out and see if we distribute and get back what we started with. Let's see. Negative 2x times 2x is negative 4x squared. And then negative 2x times 3 is negative 6x. Yep. We got it back. We got back exactly what we started with, so here's your answer. That is the factored form. If you put your original into your calculator and then you put this into your calculator, they should graph on top of each other or you mess something up.